Hello, everyone. I'm Vaibhav Arora, Product Manager for Azure Kubernetes Service, and I'm here to talk about scaling on AKS. Now, scaling can mean a lot of different things when it comes to a Kubernetes cluster. You could be running a whole bunch of pods, even if they are test pods, or you could be running your mission-critical workloads on AKS. So if you have a high-demand application, you could easily over-provision your nodes in your cluster, but this is going to be expensive because when your cluster doesn't have the high demand, all those extra resources are going to go to waste. On the other hand, you could also under-provision your cluster by provisioning it for your P50 usage, but then when you get a spike, you're going to end up hitting application issues with some of your pods even getting killed. And that's where auto-scaling comes in. It's about knowing how to scale based on the demand your application is having, both from a compute as well as an application layer. Let's first talk about scaling of the control plane. The control plane on AKS is fully managed today. However, actually getting the performance you want out of the control plane is more of a shared responsibility. If something goes wrong in the data plane, like you go from 10 nodes to 5,000 nodes, you need to also make sure you follow some other best practices to make sure you don't overload the control plane. For example, we've seen a lot of customers who just send a bunch of list calls, which they don't even know they need, to the API server, and that causes the API server to crash. We recommend using Kubernetes informers instead, which are more lightweight and tend to prevent the API server from crashing at those scales. Additionally, we've seen customers who have a rogue pod, which is going ahead and creating 5,000 objects, and they didn't even realize it was doing that. For each object you create or delete, you have to make a call to the API servers. So the larger the size of your cluster, the more likely it is that a single pod can ruin your entire performance. And that's where this diagram comes in. We kind of think of control plane as this multi-layered envelope. So if you're going from 10 nodes to 5,000 nodes, you need to also make sure you're scaling your other requirements like network and storage to meet those demands. And internally within AKS, we are doing things to help customers deal with rogue pods and prevent them from taking down the control plane. As an example, one of the recent optimizations we made was the upstream JSON streaming feature for the API servers. Does anyone know what that feature is? So with Kubernetes versions 1.33, a new feature was introduced which reduces the memory usage of the API servers by over 10x. This feature in upstream is only supported for 1.33 and above, but within AKS, we were actually able to backport it to 1.32 and 1.31. So if you are running a large cluster with 500 plus nodes, we highly recommend that you upgrade your control planes to these versions to get the latest optimizations. Moving over to the data plane, this is usually what customers care about more because this is where you deploy your applications. And you also get a lot more control on the actual infrastructure you're deploying on. One of the configurations we allow customers to make is the zonal configuration for their node pools. On AKS, you can deploy your node pools whether you're using VMSS, virtual machine node pools, or VMAS, either as zone spanning, zone aligned, or regional. In a zone spanning approach, you're deploying a single node pool across 3 different availability zones. So whenever you require a new node to be scaled up, you're relying on AKS and VMSS to do a best effort scale up in the right zone to maintain an even split. I say best effort because this can depend on a lot of things like capacity or the certain VM SKUs that you're using. The other option you have is zone aligned node pools. In this approach, you deploy 3 different node pools, 1 in each zone, and you spread your applications across those node pools at an application level. So you use things like taints and tolerances to know which node the pod needs to go to. And AKS simply scales up a node pool depending on the taints of your pod. The third option are regional node pools. This is one we do not recommend to use. So regional node pools are not guaranteed to be in a single zone. And that means that we can't give you guarantees on high availability of your application with regional nodes. So we only recommend using regional nodes for your test clusters or test pods where you're OK with some amount of downtime. So talking about node pools, We recently did GA the virtual machine node pools, which differed from VMSS node pools in the sense that you have flexibility in the SKUs you can pick. So with a VMSS node pool, you would typically pick a single VM SKU, and that would be the only one in that node pool. So you would have to deploy multiple node pools or be okay with the restrictions placed on you with a single SKU. But with virtual machine node pools, within the same node pool, you can have multiple SKUs. This helps you work towards resiliency, because if a certain region is having issues of availability of a certain SKU, you have backup SKUs in place to be able to make sure that your pods remain provisioned. Additionally, if you are running a 90-core VM, but you only need a pod which requires 2 cores, with a traditional VMSS node pool, you would have to deploy a full 90-core VM just for that one pod. But with virtual machine node pools, you can deploy a much smaller VM in that same node pool in order to make your cluster better at bin packing and more efficient. We're also deprecating availability sets on AKS, and we do have a migration path available to virtual machine node pools. So if your cluster is using availability sets, we would recommend you have a look at that document. Now, some customers might not want to deal with any of this. They might just say, I want to deploy an AKS cluster, give me whatever compute you have available. And typically, when a customer would do that, we would give them the default SKU of DS2 V2. However, recently we made a smart VM default, where if you do not specify what SKU you want in your default node pool, we will look at the quota available in your subscription and the capacity available in the given region to see which node SKU to give you. So this reduces the chances of provision failures when you're deploying a new cluster. We have a similar improvement that we've delivered in the portal as well. So if you're deploying a SKU which we know based on the internal metrics might cause issues in the future, we are going to give you alternatives you can look at, both in terms of other SKUs as well as other regions where that same SKU might be available with more versions. Along with picking the SKU for your node pools, you also need to make sure your application scale can meet your demand curves. On AKS and Kubernetes in general, this falls under 3 categories. You have horizontal pod autoscaling, you have Kubernetes event-driven autoscaling, and vertical pod autoscaling. In horizontal pod autoscaler, you effectively look at resource usage like CPU and memory to know when to trigger more replicas of your pod. Now, this can lead to you provisioning a new node as well, because you're increasing the number of replicas and your traffic gets divided among more pods. And you can make this smarter with KEDA, or Kubernetes Event-Driven Autoscaler, where you're able to use metrics like HTTP requests or your queues to know when to trigger an HPA request. The third one is VPA, where instead of deploying more replicas, you instead change the requests of your existing pods based on historic usage. So this allows you to optimize your pods a little bit better, make sure that they're not requesting more resources than they actually need, or if they are requesting, just scaling it back down based on what you've seen historically. And this all ties down in one specific area, which is making sure you're right-sizing your cluster to meet the demands of your application. No one likes spending more money on clusters than they actually need. And this is where AKS has 2 different offerings. When it comes to the scaling up of your compute, we have cluster autoscaler and node autoprovisioner. Cluster autoscaler is the same program as what is available in upstream Kubernetes, where it works with VMSS node pools, and when it looks at the pending pods, and whenever a pod goes into a pending state, if it requires a new node, it will scale up a new node for you. However, this doesn't work with virtual machine node pools, where you might want to work with multiple SKUs, or you might want more efficient bin packing. And that's where node autoprovisioner comes in. You can think of it as a smarter cluster autoscaler, and it is based on the open source Carpenter project, where it looks at the pod distribution you have in your application, it looks at the node SKUs you have in your node pool, and it picks the next node specifically to allow you to do efficient bin packing. And I'm happy to announce that just a couple of weeks ago, we also took node order provisioning on AKS to generally available. This was something customers were waiting on for a long time, but along with virtual node pools as GA, with node order provision as GA as well, you can now migrate over to this if you're using cluster autoscaler today to get better scaling in your clusters. Moving forward, this is going to be the recommendation AKS gives to our customers when it comes to having a scaling system in your cluster. And that's because we've seen customers use NAP in creative ways. So one of the ways we've seen customers use it is to optimize costs. In Azure, we have a VM SKU called Spot VMs, which are about 80% cheaper than an on-demand VM, but you're not always guaranteed to have that compute. So if you use NAP and virtual machine node pools, you can set a higher weightage for the Spot VMs while still having on-demand VMs available as backups. In this way, you can reduce costs, but still, if you have the right eviction policies in place, still be able to deploy your applications to Spot nodes. Of course, given that Spot is not guaranteed compute, we do not recommend using this in your production environments. So now that you have your compute scaled up or scaled down for your cluster, it's also important to remember that the networking configuration you have for a 10-node cluster is not going to work for a 1,000-node cluster. That's where we have a couple of features that we've built in to help you scale up your networking environments as well to match your compute scale. For example, we now have multiple SLB support in public preview, where if you're hitting SLB limits of 300 inbound rules or 8 private link services today, you can effectively HPA your SLBs. Along with that, by increasing the number of replicas, you can also map each load balancer to specific areas of your cluster, like specific nodes or specific namespaces. So in a way, you can also use this to isolate certain nodes for your traffic. So it serves as both a resiliency as well as a security improvement. We also have static block allocation. So if you're in an environment where you're running a lot of pods and you're not able to find IPs in time, or you're hitting the limits of the 65K pods, you might consider using static block allocation. This allows you to have your pods directly connected to the VNet, and you're no longer limited by the size of a single subnet or an address space. So this allows you to go past the 65K pod limit and scale up to much larger clusters. Another part of networking which we've seen a lot of customers struggle with is DNS performance and reliability. At large scales or in high traffic environments, typically the core DNS in a cluster can become a bottleneck. So we've launched, in fact, just this morning, AKS local DNS in public preview. With AKS local DNS, we're effectively giving you a DNS service on each of your nodes, allowing you to resolve your queries locally. And even the connection between the local DNS and core DNS has been upgraded to TCP to give you better reliability for your DNS queries. The local DNS service also includes a serve stale feature, which allows you to store responses locally and for the pods to continue receiving responses even if the upstream DNS servers have intermittent outages. We now support this on all Linux node pools running Kubernetes versions 1.31 or higher, and you can read more at that link below. And just to be clear, this is not a small improvement with DNS. We actually did a test internally at a large scale, so we triggered over 10,000 queries per second, and the response times dropped by 10x. There's also another graph which is not shown here, which shows the traffic distribution between core DNS pods, and we saw a much more even distribution between the core DNS replicas, even at such a large scale. We published these results in our blog as well, in case you want to read about it more. The last thing I want to touch on while we're on the topic of scale is actually going multi-cluster and multi-region. You might be in an industry where you need to be deployed to multiple regions for resiliency, or you might even have latency requirements if your customers are spread around the world. But with more clusters, there's a lot more to manage as well. And that's where AKS Fleet comes in, where it helps centralize the management of all these clusters. And with things like workload placement, you can deploy the same application across all these regions at once. We even did an internal POC to test how far you can take the fleet, where we deployed over 80 clusters across 7 regions. And we deployed about 950 nodes in each of those clusters. So in total, we were running about 70K nodes and 140,000 cores because they were 2-core VMs. And we were able to divide our application across all of them and even load test to make sure that the application is working fine. Now, when you actually think about that, that's a lot less than what our clusters can actually support. You could scale up each cluster to go up to 5,000 nodes and then deploy over 100 clusters in your fleet to reach even higher limits if that's what you would prefer. One of the ways we've seen customers use Fleet is also to manage auto upgrades. So instead of deploying the same application across all of their clusters, they deploy certain clusters as test clusters, which they upgrade first before enabling a soak time and then eventually pushing the upgrade to their production clusters. This helps because in case there's a breaking change in the upgrade, you can detect it while you're in the test phase and prevent the upgrade from going further into your production environments and prevent your application downtime. This works especially great with some other features we have within each cluster when it comes to your upgrades. For example, if you look at max unavailable, it allows you to configure how many nodes can be taken down at a time when you're upgrading your cluster. So I was talking to some customers out there who were interested in GPUs and using it for AI. One of the biggest struggles customers have with GPUs is you trigger an auto upgrade and your node pool starts scaling up because you need those extra nodes. And then all of a sudden you lose your previous nodes because someone else stole them from you. If you set max unavailable to 0, or max unavailable to 2 and max search to 0, you won't lose that GPU capacity you had provisioned for yourself, and you can make sure that after the upgrade goes through, you'll continue to have access to those GPUs. Additionally, we've also released AKS Component Insights, which gives you a more of a programmatic approach to breaking changes. So with specific Kubernetes versions, you can see what changes are made in each component, allowing you to prevent, again, breaking changes that might happen if you upgrade your cluster. We also have a similar offering within the portal where you can now check for things like bad PDBs, or if your cluster is in a stopped or a failed state, which could cause issues if the upgrade was to actually go through. All right, so now we all know how to get to 5,000 nodes in AKS, so we all deploy the clusters. But things can still go wrong. You could have a node which hits resource limits, you could have a pod which gets killed, and that's where observability becomes important. You need to know what is going wrong and where in order to actually be able to respond to downtime and make sure that customers don't stop using your applications. And this is where in AKS, we're not just looking inside your cluster, we're kind of thinking about it more from a platform perspective, where we're taking a bird's eye view not only of what is in your cluster, but also what is coming to your cluster. So you can use tools like Network Watcher or Traffic Analyzer to visualize, monitor, and even troubleshoot your security and network issues across both your Azure and hybrid environments. Then you can use Azure Monitor to kind of connect all of these metrics with metrics from your cluster using tools like Prometheus and Grafana in order to actually get end-to-end metrics from your infrastructure all the way to your application level. You can also integrate this with Azure Container Network Services, or ACNS, in order to get more pod-level statistics, giving you a complete end-to-end view to know exactly where the problems are being caused. And that's why we're announcing the public preview of connectivity analysis for AKS. So when we talk about end-to-end, one of the biggest issues is you might have a network flow going from your pods or going to your pods, but you don't necessarily know which component in that path is causing your downtime. So you can try out network analysis in the node pool tab today, where you can actually test those network flows. You can put in any public endpoint and run an analysis, and it will tell you what component along that path is actually causing the breakage in your network flows, and even potential reasons why. Additionally, we also have container network logs when you're using ACNS. It provides you with detailed visibility into the network traffic between your containers, pods, and external endpoints. So you can capture things like HTTP traffic data, which helps you speed up all your troubleshooting and auditing, especially when things go wrong. You can use this to detect things like suspicious traffic patterns, so make your cluster more secure. Or if you have performance requirements, you can also use this to identify sources of latencies to know what kind of component is causing your responses to be slow. Let's see a demo of this in action.
Containerized applications are at the heart of modern innovation, and understanding their network behavior is critical. Today, we're excited to introduce ACNS Flow Logs Unlocking AI-Powered Insights for AKS Networking, a groundbreaking approach to monitoring and optimizing container network traffic. Container network logs can be stored in an Azure Monitor Log Analytics workspace or an external logging service. Logs can be queried on the workspace and viewed in the Grafana dashboards. Here we can see there are no logs initially for a demo namespace. A Retina Network Flow Logs CRD is applied. It helps filter to generate logs only what's relevant to optimize on cost. Container network logs provides granular logs enriched with network metadata like pod identities, namespaces, TCP, DNS, and HTTP. For DNS traffic, flow logs would include metadata like request, responses with FQDNs being queried, and for HTTP, information about error codes, methods, and latency for a given HTTP response is available. Pre-built Grafana dashboards surface top network concerns like dropped requests, DNS, HTTP errors, and total flows. It also provides a service dependency graph, which shows the communication between various workloads in a single pane of glass, and any issues are marked with a color-coded arrow to indicate problems. Additionally, logs can be queried for the selected filters with ease. With the power of Azure MCP Server and its integration with GitHub Copilot Agent Mode in VS Code, container network flow logs can be used to seamlessly analyze network traffic patterns in real time. In this demo, the agent parsed the logs and generated a comprehensive report highlighting outgoing network drops, identifying the directionality of traffic, the most affected workloads and services, and pinpointing the root cause as network policy over restriction. Developers were able to interact with the agent using natural language to uncover insights, enabling faster troubleshooting and a more intuitive observability experience directly within the IDE. This tight integration streamlines observability, turning raw network data into actionable insights using AI. Thank you for watching. Hope this gave you a glimpse into how AI and cloud-native observability can simplify and accelerate network troubleshooting.
All right, so a lot of what we spoke about so far was looking at actually getting observability into the stuff that's coming into the cluster. So let's talk about what we're offering now in terms of observability in your cluster. We now support dashboards with Grafana in public preview within the portal itself. So you can now create and edit your Grafana dashboards at no additional cost within the Azure portal. This helps you reduce things like your operational overhead because everything's centralized within the Azure portal itself. And you can also make this more powerful by using the integration with Azure RBAC to assign things like permissions and create automations for what you do with the metrics you record. And as Pradeepa mentioned all the way at the beginning, AKS is also doing a lot of things to kind of make onboarding onto Kubernetes easy for you. So one example of that is auto-instrumentation for applications. So this is effectively a tool which allows you to enable monitoring for your Java and Node.js applications without actually making any kind of changes to your application code. Additionally, we're also making improvements and making the process simpler for you to actually onboard all of these tools onto your clusters. So within the portal, we've created this unified onboarding experience, which lets you enable most of these features within one click. But if you have specific kind of customizations you need in order to meet your application requirements, you can even configure smaller settings, which just take a few additional steps. Some of the other observability improvements we've also delivered are managed Prometheus visualizations, Prometheus community recommended alerts, and then simple log alerts in public preview. So that wraps up a lot of the announcements we had. We have a lot of features in development with public previews and even GAs. And if you'd like to stay up to date with a lot of what the team does, most of our stuff is posted on public sites. So for example, you can track our roadmap on GitHub, where we updated in almost live. And you can keep track of what are the next features in the pipeline. Along with that, you can read some of our blogs in our engineering blog as well. So we would highly recommend, if you're more interested in learning more about AKS, check out all of these resources. All right, so that wraps up all our content for today. Thank you everyone for joining. There are some resources available here in case you want to get in touch with our team as well. And yeah, now we'll move to Q&A.